All right, so we're on, all right, the number here, number 11. All right, so this is number 11. Determine the density altitude. So we're looking for the density altitude for these conditions. The altimeter setting is at 30.35. Runway temperature is positive 25. And airport elevation is 3,894. So let's look for the altimeter setting. So the altimeter setting for this question is 30.35. So we do not have 30.35. 30.35 would go in between 30.3 and 30.4. Since that is not there, we need to find out what it would be. It would be exactly halfway in between. So we can find the average or the mean rather of these two numbers. So that's 348 plus 440, just taking the absolute value of each number. I may get 788. So we are dividing this 788. After we're done dividing it, we get about we get about 300 and I'd say 300, yes, 394 would be the mean. So that's all we need to know there, 394. So we'll write this up here. So the altimeter for 30.35 is 394. Next step is, after having that, we need to add that number, subtract the number from 3,894. So we have 3,894. We subtract that from 394. When we subtract that, we get 3,500. Now, having that is not our answer though. We have one more final step. So we have 3,500. So now we come to the chart and we look at the approximate density altitude, because we're looking for determine the density altitude. So this number here is our pressure at altitude. So our pressure altitude 3,500 goes, well, more or less something like that. All right, that's our 3,500. That is our pressure altitude. Let's come down. So the number we're giving for our temperature is plus 25. So 25 would be somewhere around, will be this line here. So all we have to do is go up. We intersect at this particular point. And that particular point correspond with this line. And therefore, our density altitude after doing these steps is 2,000. We just have to add, each number represents 1,000, so 2,000. So the answer is 2,000 for this particular problem. 2000. Now for number 12. Number 12. What is the effective temperature increase from 30 to 50 Fahrenheit on the density altitude if the pressure altitude remains at 3000 feet MSL? So this is a two-step process. So 3000. Well, we have our 3000 line, which is this. All right, I'll write number 12 here. Now we have to find our 30 and 50. So let's do 50. So our 50 intersects at that point, which is about, it's near 3000. So I would say, maybe about 2900. All right, then our 30 is the next one. Intersects at that point. It looks about 1500 to me, more or less. So let's say 1500. We have to subtract these two to get our answer. And that leaves us with about 14. So from the choices, the answer is C, 1300. We have 1400 more or less. "13. What is the effect of temperature increase?" Oh, we did, no, this is a different. What is the effect of temperature increase from 35 to 50? On the same line, 3000. So here's our 3000. It's going to be the same. We have 35, which is here. And that seems to be about 1500, I think. 450, which is over here. We said 2900. Same process, subtract. Something close to 1400. I believe I had made a mistake. Let's go back and see what I did wrong. So we're at 3000. 35 is over here. That's at about, I would say, 1500. Because we're at 35. Next one is 50, which is about here. That looks to be about, yes, 30 seems to be about 2900. And then, excuse me, 50 seems to be about 2900. And 30 seems to be about, I would say close to about 2000, maybe 1900. So when we subtract that, we get 1000. And then looking at the answer, that's 13A, 1000. All right, 14. What is the effect of a temperature decrease and a pressure altitude increase on the density altitude from 90 Fahrenheit and 1250 feet pressure altitude with 55 and 1750 feet pressure altitude? The discussion says the requirement is the effect of temperature decrease and pressure altitude increase on density altitude. First, the density altitude at 90 and 1200 feet, approximately 3,600 feet. So let's do that. So we have 90 feet and 1250, 90 Fahrenheit, excuse me, and 12,050. So 90 Fahrenheit is here. All right. The next number is 55 Fahrenheit, which is over here. Now we have two different numbers, or two different density altitudes or feet pressure altitude. So the feet pressure altitude for let's do 55. The feet pressure altitude for, well, we'll do 90 first. For 90 is 1250. So 1250 is near 1,000, so we'll put it somewhere here. So, all right, so we'll go up. And we'll say that intersects approximately at, well, it's above the 3,000 and so forth, and above 3,500 appears. So we will say about 3,600, right? Because when we look at this, it's above or right at it, 3,500. We can say that, let's say 3,500. All right. Now the 55, its number is at 1750. So that's going to be closer to the 2,000. So let's say that's about here. So we'll go up about there. And looking at that, it's about that's about at the 1,500, I would say, more or less. No, maybe more. Let's say about 15, because this chart is not clear, but let's say 15. And then from this, we subtract. When we subtract, I get 20,000. I mean, 2,000. So more or less something of that. Now we're starting with this higher number and we're going to this lower number. So we're subtracting higher to lower. So there's a decrease. So the decrease is about 2,000. And our answer, we have 1,700 foot decrease. So the answer would be C for number 14. All right. Keeping on with this particular chart, let's do number 15. Number 15, determine the pressure to altitude at an airport that is 350 feet MSL, 3,563 MSL with the altitude meeting setting of 29.96. All right, let's read the theory. All right, so note that the question asks only for pressure altitude. So pressure altitudes are these lines. All right, it's asking for pressure altitude. It's determined by adjusting the altimeter setting to 29.92. That's standard. Adjusting for non-standard pressure. This is true altitude, plus and minus or pressure altitude. Based on the current altimeter setting on the chart, an altimeter setting of 30 requires you to subtract 73 to determine the pressure altitude. Note that 29.92 subtracted because that is the pressure altitude. Since 29.96 is halfway between 29.92 and 30, you need to only subtract 36 from 3,500 feet to obtain the pressure altitude, and so forth. So this should be relatively easy to obtain the answer. So let's look for 29.96. So we have 20.9 52, and we have 30. So 20.96 would be in between these two, more or less. So what we can do is we can add these two numbers together, which is 73, divide by 2 to get the mean. And we get roughly 36, 36.5 if you want to be exact. Right, the book sticks with 36. So it will be 36, the altimeter, for 29.96 is 36. And the pressure altitude, that is, I mean the feet MSL given, is 3,563. So all we have to do is subtract 36 from it. That should give us our answer. Oh, 5 minus 3 is 2. 3,527. All right, so that is our answer for 15. 16. Determine the pressure altitude of an airport that is 1386 feet MSL with altimeter setting of 20.97. So same philosophy as the other one, more or less. So 20.97. Well, once again, same situation. But it's not exactly halfway. But I think we can use the number though, we can try. So halfway between was about 36, right? So let's try using 36. And the number given is 1386. We'll subtract 36. And we get 1350. And the closest number to 1350 in this case is A, 1341. It will be less because 36 is actually too high. It should be a little bit lower than 36. So that solves number 16. Number 17. What is the effect of a temperature increase from 20 to 50 on the density altitude if the pressure true altitude, right, remains at 5,000? So we're looking at 5,000. We want to see the difference between these two. So we have 25, which is here. Let's go up there. So that looks about, approximately maybe 3,900. More or less when you look at the line. Maybe 3,800, maybe be better. 3,800, okay. Next is the other line, which is at 50. 50 is over here. I guess it touches the line, not sure. So we'll say that well, my mistake. 50 goes up to, what's the number it says? Yes, it's also at, it goes up to 5,000 feet. So there we go. That is about, about 5,000 or maybe at 5,000. I'll say, no, it's actually above 5,000. 5,000 is right here. So let's say 5,500. Actually, it's less than that. So 5,400. Let's say 5,400. And let's see here. So now we need to do the subtraction to see how much is the difference between the two. And we get about 1600. And the answer, textbook answer, is 1650. So that's great. Now, the next problem is a little bit unique compared to the others. Determine the pressure threshold altitude with the indicated altitude of 1380 feet with an altimeter setting of 28.22 at standard temperature. Where in the other one, what is the effective temperature increase? So here we don't see this particular word. So here we are adding, whereas the other ones we were subtracting. So let's look at this. We have 28.22. 28.22. That's a little too small. So I'm just going to stick with this. That's not 28. Let's go up a little bit. 28. This is 28.22. That's a little small. So I think I'll just stick with 1630. I think we can make do with 16. I'll write that here. 1630. 28.22 is getting higher, so the number would get lower. So we could even put 1620 maybe. All right. Now, it could be even smaller. Now, putting that aside, let's see here. Now we have 13. We have 1380. Or, you know, we can just keep it at 1630. I think that's what the book did. Now we have 1380. So I said 1630. So the book is using interpolation, but it's kind of confusing, but we know it's going to be maybe around 1620. But all we're doing is adding. So when we add them, 1380 here, 1380 here, let's see, 0, 10. That's about 33,000. And here, so we know it's going to be towards this side, but not too much lower than that. So about that, the closest answer to that is B, 2,991. Now, what the book is asking is it gets a little bit technical with the math, but if we do it like this, this should be just fine. All right, next problem is 19. Determine the density altitude of these conditions. The altimeter, determine the density altitude. So we're trying to figure out one of these numbers, all right? So 29.25. 29.25 is not given, but we can find it by adding and finding the mean. So we have 673, 579. So that leaves us with 1292, right? 1292 into 2. And that should give us about 5, 6, but it looks like about 629. Yes, 629. So let me just write that. 629, right? So 629. Now, next is our weight is 5,250. All right. Our per elevation rather is 5,250. And our runway temperature is 81. So we have to add that number to our 5,000 to 5,250. Okay, so 5,250 plus 629. So we get 5,879. So we need to find that particular pressure altitude, 5,879. Oh, well, that's going to be close to the 6,000 mark. Maybe something like that. And our temperature is at 81. Somewhere maybe here. So we're going up until we come to this point. And let's see here. Now, is that past 8,000? Let me check. Oh, that's past 8. Excuse me. That looks like to be at 8,000. So maybe the answer in the book is 8,500. So the answer then is C. We got close. We said about 8,000. Maybe I drew the picture poorly.